Hi folks, this is the video tutorial for homework number 5, and the difference between the one for lab 51, which is right now what I'm doing, and lab 52 is the fact that here we are asking you to submit problem 1, whereas in lab 52 we are asking you to submit problem 2. So for this tutorial, which is 51, and you're responsible for problem 1, I'm only going to do this one, okay? Uh, but if you want to see how problem number 2 is done, go to the tutorial for lab section number 2, okay? Now, this problem, this is a hybrid problem. You look at this, immediately you should realize that this has to be done as a hybrid problem. In other words, that guy in the middle, that box in the middle should be meshed with solid elements. This thing, which looks like a plate, it should be done with shell elements, and these legs must be done with beam elements. Do not model everything with solid elements. That's a substantial reduction of marks. Okay, now it says use all planes of symmetry, if applicable. So these ends are clamped, and you put 500 pounds, and this is all symmetrically positioned. You can see that. Therefore, what we need to do is model only 1/4 of this entire gadget. Okay? And obviously, I told you most appropriate element means do not use all solids. Solid, shell, beam. Now, I have done in class these problems mostly with a single part. I did it as a single part. However, this can also be done as as an assembly, where I make a part which is just that block in the middle, or 1/4 of it. I make that plate as a part, another part which is just a quarter of it, because I know I'm going to be cutting it, and finally I just do a third part which is just this leg. So it's up to you how you want to do that. In this tutorial, in this video, I will first do it as a single part, and after I've done it, I'm going to come back and repeat the same thing as an assembly, and it's entirely up to you. Okay, good. So let's go ahead and do it as a single part. So we start with a part file. Part, okay. All right, and remember, I decided to do only 1/4 of the model instead of making the whole thing and then start splitting it with a saw. Okay, so let's do the plate first. On this, well, let's do the block first. Since we're doing the block, obviously we have to go to the part design. There's the part design. On this plane, I will sketch a square, which is let's see now, 1 by 1. That's 1/4 of that big rectangle that you see in the middle, because the whole thing is 2 by 2. So I'm doing 1/4 of it. So that means this is 1 by 1. All right, exit. And I'm going to pad it symmetrically 2 inches up, 2 inches down. 2 inches up, 2 inches down. That means mirror extent, 2 inches, automatically do 2 inches up, 2 inches down. Very good. Now, why don't we go and save this thing, by the way? Files, save management, save as. Okay, so desktop, new folder. I'm going to call this thing homework 5. Homework 5. And I'm going to, let's see now, I'm going to call it lab 51. Okay. And just so that there is no confusion, I will make this thing as a single part. Single part. Okay, good. Let's go ahead. The part, remember, we follow the strategy in our course. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's your student ID number. And I will call uh, this as, uh, how about, let's see now, I'm going to give it a good name. How about Sai Wu? Sai Wu is a famous uh, criteria in composites. So that's your last name, Sai Wu. Okay? And this is going to be part, I'll call it symmetry used. Okay? I will use symmetry. Symmetry used. I'll say, how about one quarter model? Quarter model. Very good. Excellent. Save it in there, and we move on. Now we're going to create 1/4 of that plate. So first of all, we switch to generative shape design because I want to create a surface. On that XY plane, I will sketch again a rectangle, which is this time 2.5 by 2.5, like that. Because the entire plate is 5 by 5, I'm doing 1/4 of it, so this is going to be 2.5 by 2.5. 2.5. Okay, exit. Now, I want to put a surface through this. Okay, so the easiest way for this particular problem, when you have a closed bounded curve, you say to go to not extrude, don't extrude, FIL, fill, FIL. You select it and you say, okay, there we are. However, I want a cut here. So what I can do is that say on this plane, on this surface, the sketch. Why don't the easiest way is to project that surface onto that plane, and here's project. There are other ways of doing it. By all means, go ahead and do it the way you want. And right there, you see this? Right there? And then you say, okay, exit. And if it's bothering you, let me hide this. And now say split. Where's the split? Here's the saw. The split, read this thing carefully. Element to cut is that surface. Cutting element is that thing that you projected. And we obviously want to remove this piece and keep the rest of it. Up to you how you want to do it. So let me bring this thing in the front so that you can see it right here. Okay? Anything that's bothering you, you can hide. For example, these sketches you can hide. This sketch you can hide. Okay? There we are. Now, save it. Then we're going to create the leg. The leg goes from here all the way down by a distance of 5 inches. So why don't we do the following? We say, okay, let's create a point. And there are different ways of doing it. For example, if you know what the coordinate down here is, type it. And I know what it is. Just look at your drawing. That is going to be uh, 2.5 minus 5. So x is 2.5. Okay. Uh, y is 2.5. As I said, there are different ways of doing this. Minus 5. And there is the leg. There is the leg. Okay. Excellent. So let's create a line between this point and that point. There's the leg. And obviously, if you look at 4 of these, put it together, you get the drawing that you see right there. Okay? All right, save it. Let's make everything out of steel because you're told the entire assembly is made out of steel. So metal, steel on the entire part. And we say okay. And we are pretty much done here. So now we're going to go to generative structure analysis. CATIA sees a solid object. Immediately it measures it. Look, it measured it. Okay? You can make the element smaller, you can make it bigger, you can make it parabolic or linear, etc. So we just leave it the way it is. Okay? All right. Now, uh, this surface, we have to measure it with shell elements. So there is the shell element, or what CATIA calls octree triangle measure. And the size, okay, no problem. We're not assessing accuracy here. And let's put some thickness on this. So 2D property on this. Now, what is actually the problem statement? It says the thickness is zero point 0.1 inch. And what do I have here? Yep, 0.1 inch. Just coincidence. We're going to mesh this thing with beam elements. Select that. Beam elements are very versatile. Doesn't matter what the size is that much. Why don't I make it 1? Okay, so there's going to be 5 of them through this. Okay. And the cross section, 1D property, it is circular. You're told it is circular. So all you need is you select the radius of that leg. Oh, let's see now. It says here 0.05 inches. Oh, no, wait a minute. 4 legs are circular with radius that. Okay. Yeah, good. So 0.05. I think that's very thin. But I'll leave it the way it is. Okay. And because this is circular, there is no cross section. There's no orientation point. You just select it, and there we are. If you look closely, you put a circle there. Okay. All right. You say okay. All right. So what do we save our analysis? Files, save management, analysis, save as. Let's see now. Where is that folder? The folder was called Homework 5, Lab 51, single part. And remember what we call this thing? Student ID number 123456789 dash your name Saiwu dash quarter model. Remember, we're doing this thing as a single part. Okay. Excellent. Okay, so what do we know? We know that the bottom of this is clamped. Clamped, don't put it on point. You're going to have a problem. Don't put it on point. Hide the point. Put it on the vertex. You can put it on the point, but then CATIA will not see that. Point is not a finite element entity, and basically this is going to be flying away. Okay. Now, symmetry. Okay, be careful here. Surface slider on this surface that you cut in the solid and that surface. Excellent. And using these are symmetry for shells, you see that? So you're going to go user define restraint. Let's uncheck everything. You look at this. It is in the XZ plane. Oh, make sure it's not user. Don't use user. Global. It was user because I don't know. Last week when I did the problem for you, it was user and stays like that. Unfortunately. Okay, so this is in the XZ plane. Does not move in Y, and rotations opposite. Oops, not that one. Opposite. And the side. This side. User-defined restraint, this edge that lies in the YZ plane does not move in X. See that? It lies in the YZ plane of global system, does not move in X, rotations opposite. Now, we have a load of 500 pounds on this. If you don't want to lose any marks, don't put 500 pounds there. You took a quarter of that, so you put down 125, right? 125 pounds. Don't convert it into pressure. We ask you to put a force, you put a force, okay? So 125. Remember, these things don't have part marks on the test. do it exactly like what we asked you to do. So this in the direction Z minus 125, which is a quarter of 500. You can see that direction is correct. Now, if I run this thing, it will bomb out because this block is not by any means attached to that surface. So we have to create connections. We have to create connections. Why don't we first create a connection between the end of this line and the vertex of the shell? So first connection here, I'm going to name these things, okay? So I say end of line, end of, okay, end of line, vertex of plate. How about that? Vertex of plate. Okay, so let's be careful here. First component, I don't want to screw this up, so I'm going to hide that surface first. If I want the end of line, I select it, and then I have to go and select the vertex of that plate. So bring it in the front, hide the line, try select this point. If you can, just hide the connection. There we are. You see this? Now you can select it. That white dot was sitting there blocking our view. Now this is going to be a rigid connection. When you have a point to a point, it must be rigid. Think about it. Point and a point. Hey, there's no deformation there. It's just a rigid. Okay. Now we can do that now if you want. So this is the one that I created. You see this? This is the one that I created. So why don't we make it rigid? Now rigid, you're not going to see it in face to face. Okay, face to face is not. It's not in face to face. What you need to do, you look at your connection properties here. You see that? The first one is face to face. The second one is, let me make it horizontal so that you can see it better. This is where you have rigid, right there, rigid connection, rigid connection. You click on it, you select that, and you say OK. Nothing fancy happens here. Basically, you have a rigid connection. Now, I also have to connect the edge, the entire block. And there are different ways of doing it. The way I'm doing it for you is the entire block with that surface. Okay, so another connection, I will say block and block slash surface or plate. I call it plate. Okay. First component, it's entirely up to you. You can select the surface or the plate. And for the second component, you can go and select this the entire block, okay? So you go to the link, select the pad, okay? So where is that? Expand this and select the pad, okay? You could have also done it this face and that face or the plate, this face and the plate, okay? You could have done it that way, but I didn't. Okay, save everything. And we're going to run it. Okay. By the way, if you look at your mesh, before I run it, let me show you the mesh. Right-click Mesh Visualization. You're going to see all of them appearing. These are the solids. These are the shells. And these are the beams. Okay, so let's go ahead and run. Okay. All right. Now, it looks like something I didn't do something properly. So let's see what happens here. Obviously, this didn't run, so let's check it out. Let's do the deformation. This deformation. Okay. You see what happens? What happens is that it looks like when I did the block. You see that? I did the block. Remember, I went to the pad on it and I did it. Do you remember that? And I went to the surface. Okay, it looks like it doesn't like that. So what I'm going to do instead, I'm going to do the face of this block. I thought it was going to work, but it didn't. The face of the block and that plate, and the face of this block and that plate. So cancel that. We know what the issue is. Okay. Uh, oh, no, 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 no. I created the connection, but I never actually declared it. That's why it's running away. Never mind. You can do it exactly like I did. It's just that I did not say what kind of a connection it was. You see that? I defined the rigid one, but I forgot to do this. Take back what I said. Okay, this will work. Just deactivate this and face-to-face connection. Where is the face-to-face connection? Get it? Fastened right there. Fastened. See, I defined my connection, but I didn't say what kind. And then we say, okay, notice that it did put a fastener sign in the middle, okay, and save it and run it. This time it will work. What I said is also going to work between the face and the plate, the other face and the plate, but it's not necessary, as you will see. Let's run it and see what happens. This time the block will move and will carry the plate with it, as it's supposed to. Yes, yes. There we are. Let's change the scale. Right there. Hey, right there. Excellent. And you can animate it. And you can look at the stresses. Of course, not the stresses in the beam, but you can look at the stresses in the block, which is very little, by the way, because it's a very sturdy block. It just moves pretty much as a rigid body. But there will be stresses in the shell for sure. Right there. Change the rendering here to material shading. There we are. Okay. Very little stress in the block. Very bulky. You put a load on it. It kind of moves as a rigid body. This is it's going to carry the shell with it. Okay. So let's kill this. I'm going to repeat the same problem, except that I will do it as an assembly. Let me kill that and kill that. And we start with a product. Product. Save it right away. File. Save management. Save as. I'm not going to put in the same folder. I'm going to go to my desktop. I'm going to create a new folder. And we call it, what did I call this? Homework 5. Homework 5. Lab 51. How about calling it assembly? It's up to you how you want to do it on the test or on the homework. We don't care. And just give it a name. Your student ID number 123456789 dash Saiwu. By the way, Stephen Tsai was a professor at Stanford University, and he worked at NASA before. I think either NASA or Wright Patterson Air Force Base. So I think he's dead now. So this is calling a quarter model. Quarter model. Okay, doing it as an assembly, obviously that's a product. Say okay. We say okay. Good. Insert the first part. Insert new part in there. And remember, I told you that I would like to rename these things. I will leave it to you to organize your work. It's up to you. But I will call this thing the block. 1, 2, 3, 4, 5, 6, 7, 8, 9 dash Saiwu block. Okay, quarter model. Quarter model. Okay, and this is the instance name. Copy, paste here. Okay, there we are. Let's make it. Let's go into the part design. On that plane, I will sketch. Okay, I will sketch that 1 by 1 quarter of a block. Remember that? 1, and this is 1. exit, padded, mirror extent, 2 inches in each direction, and there we are. Okay. All right. So let's go on the top, on the very, very top. Click on the floppy. So what's going to happen is going to obviously save the product and a part in it, which is by that name. Let's check that. So where is this? Is it this one? Yep, right here. There is your product, and there is your block, quarter of a block. This is the product, and this is the quarter of a block. Go back there. Second part, insert, new part in there, okay? And you change this thing, right click, properties, 1, 2, 3, 4, 5, 6, 7, 8, 9, dash, Saiwu, dash, plate, okay? Quarter, quarter, okay? Say okay. Now, I forgot to call the part names. This is the, so right click properties. I forgot to copy and paste this. Right click, copy, and down here, paste. There we are. Let's make it. Double click on it. On a convenient plane, on that horizontal plane. Now remember, last time I drew a rectangle here, a 2.5 by 2.5 rectangle or square, and then I projected that face onto it and then split it. I can do the same thing, or I can actually make that thing with a cut in it. This time, let me do it like that, with a cut in it, okay? Up to you. We don't care, as long as you do it right. Okay, well, first of all, this thing, I didn't mean it to be up there, so let's make it here. Let's make this thing coincident. Very good. Let's put dimensions here. Okay, so dimensions, the distance from here to here is 1. Control Z. Let me delete this dimension. What is this? Okay, let's make this thing 1. Yeah, fine. Okay, and dimension from here to here is also 1. See, that automatically kind of makes that cut for you. And this is 2.5, 2.5, and this is 2.5, 2.5. And you say, okay, and you exit, and you fill it, F-I-L-L. But of course, you can't be here. You have to be in generative shape design. When you talk about surfaces, you have to be in here. And use the F-I-L-L right there. So we say, okay, and let me hide this thing for you to show that actually we made the same thing, except that directly without projecting and using the split. That's fine, no problem. Okay, let's go back. Go all the way to the top. Save everything. Floppy. Okay, good. Now let's insert the third part. Insert new part. Say no. Right click, properties. And I'm going to call this thing 1, 2, 3, 4, 5, 6, 7, 8, 9. Saiwu. Saiwu. The leg. How about the leg? One of the legs, right? Okay. Again, I forgot to change the instance name. Properties. Copy. Paste. Say okay. Let's make it. Double click. Basically, we need a line here. So what I did, I created a coordinate 2.5, 2.5, or a point 2.5, 2.5 minus 5. There we are. I created a line from here to there, You say okay. Now, because I created the line, I don't have to join it. But if I had the sketch, remember I have to join it. But if in doubt, join it. I'll join it. I don't think I have to. But true, you try. Okay, good, good. That's pretty much it. Let's make everything out of steel. Go all the way to the top. First of all, make everything out of steel. Metal, steel. On that, we say okay and save it. The rest is just like before. So we switch workbenches, generative structure analysis. CATIA sees a solid object. Immediately, it meshes it. It did right there. Then we do the rest of it. Anything that's bothering you, you can hide. Right-click this, hide the sketch. Okay. We're going to mesh this thing with shell elements. This surface. Same information. Put a thickness on it. Same 0.1 inch. Then we're going to do this thing with beam elements. If this was a sketch and you had not joined it, you would not be able to select it. But I'm pretty sure with wireframe would have been okay. Okay. As I said, try it. 1D property is this, same information, same radius and everything. We say okay. All right, very good. Let's apply our restraint. Let's save our analysis, by the way. File, save management, analysis, save as. In that folder, I'm going to call this 1, 2, 3, 4, 5, 6, 7, 8, 9 dash Saibu dash uh, assembly, right? Quarter assembly. How about that? Quarter assembly. I'm doing it as an assembly, not as a single part. And it's up to you how you want to do that. Okay, let's see. Clamp this bottom, not the point. Hide the point. That vertex. Okay. Pressure. Let me change the rendering here. This color hurts my eyes. So force. Right there. Remember, 1/4 of 500, which is 125. Okay, very good. Let us do restraint. So surface slider, just like before. Surface slider on this face and on that face. Okay. Now symmetry for shells. Okay. So this one. Now let me see. Now let me uncheck these. Okay. Let's say shell symmetry. How about that? Shell. Why don't we select this? Like right there. This thing lies in the XZ plane. So I say XZ. Okay. And this is global. That's good. So does not move in Y. Rotations opposite. Very good. Let me do the other side. User defined. This edge that lies in the YZ. YZ symmetry. Okay. And YZ symmetry does not move in X. Let me uncheck all of these. Does not move in X. Rotations opposite. Okay. Save everything. Now remember, you have to create connections and then declare the connections. So let's start with the connection between end of this and that. So connection between, let me hide that. Select the end of the line. I'll call this thing line, end of line, and plate. How about that? Just so that you remember what you have done. And for the second component, I have to select the corner of this plate. Let me hide and show. Hide this guy. Hide that connection, because when this connection is there, you can pick that. There we are. And this is going to be rigid, right? Why don't we do that right now? Just right now, we can call it rigid. Now, this is a distance connection property. Rigid is right here. And this connection that you created, you can select it from the tree. Very good. Now, then you need the connection between the pad and that surface. Okay, so connection. I'll call it between pad slash plate. How about that? As I said, you can also do it between this face and that plate and the back face and that plate, but this is easier. So for the first component, you have to select the path, but you can pick it from here. You can see that. So the easiest way is to expand the tree, expand the link. You end up your part, go to the first part, block, right there. There we are. There's your block. And there is the path, okay? And for the second component, select that plate, okay? We say okay, and this is going to be fastened. Remember, I forgot about it in the first try. So fastened is a face face. Where are the face? These are the face faces. Okay, face face is right here. Fasten connection property, and the one that we just created, that connection that we just created right there. See, puts a fastener sign. Ah, right there. You can hardly see it here because there's other stuff right there. You see this? And save everything, and I'm pretty sure we're good. Save everything. We're good. We're going to run it. All right. It ran. It ran. Okay. Let me move these things out of the way. Let's look at the deformation. There we are. Okay. Look at the stress. Change the rendering. There we are. Okay. Now remember, colors look good. If you're doing this thing for a living, you have to worry about numbers too. So save everything. Let's check our folder. I want to show you what happened here. In our folder, you had the product. There is the product. There is quarter of the block. There is the leg. There is the plate, quarter of the plate. And of course, there is the analysis. So if this was a test problem, and this has been a test problem, you give all of these things to us. If you're doing it as an assembly, you have to give us the product, the 3 parts, and the analysis. If you're doing it as a single part, as I did the first time, okay, that's not it. First time, you're just going to give us the analysis and the part. Okay, let me see if I can find it here. Yeah, I can't find it here. Right. Okay, so if you're doing as a part, just give us the analysis and the part. But if you're doing as an assembly, as I did, you have to give us the product, all the parts, and the analysis. That takes care of this homework for group 51. Now, if you want to see how problem 2 is done, then go to the video for lab 52. Okay, otherwise this becomes too long. Again, I'm going to do this thing both as a single part and as a product. But on the test, you do only one of them, or on the homework, you do only one of them.